All right, so we got this car. It's being pushed by the mechanic. They tell us here, right here, neglecting friction. So that makes it simpler because there's only going to be one force doing work. Look, if there's only one force doing work, what's the net work? The work done by that force, right? If there's only one force doing work, then the work done by that force is the net work. Okay, so let's just look at the forces here. So this car, we have mg down, we have normal force up. Those forces won't matter though. Why are those forces not going to matter? They're not doing any work. Why are those why is the normal force in mg not doing any work? Because they are perpendicular to the motion. The motion of the car is going to be this way. So let's see. The car moves 25 meters to there. That's our delta x. That's the displacement. The displacement's 25. So then the only force doing work is this force that the mechanic exerts. So the mechanic is behind the car here, and he's pushing. So we don't know that force. Okay, but we do know that the work done by the mechanic, the guy does 5,000 joules of work in pushing the car. So that's the work done by this force right here. Does that make sense? So we know the work, but we don't know the force. We know the mass of the car. The mass of the car is 2,500 kilograms. And then what we're asked to find is the velocity of the car over here. And we know that the car starts from rest. It says here that the car starts from rest. Okay, so work net is equal to kinetic final minus kinetic initial. What's kinetic initial if the car starts from rest? 0. Okay? All right, so now we're left with work net equals kinetic final. Now what is work net going to be? What can we plug in for this? What's the basic work equation? Work equals what? F times displacement. Force times displacement is the work equation. Now, if you're talking about work net, then this is going to be force net. But look, what's the net force on the car? The net force is what? That, right? Oh, you know what? I think I'm solving for part B right now. Okay, this is kinetic final is 1/2 mv final squared. Wait, guys, hold on. Scratch this. I made a mistake. Here's what we want to do. We know what the net work is. Sorry. The net work is what? 5,000. So plug that in here. Sorry. 5,000 joules is the net work. We have the mass. So now we can solve for V final. So V final is going to be square root of 2 times 5,000 joules divided by the mass, which is 2,500. So this comes out as square root of 4, which is 2. So the velocity, we now know the V final is 2 meters per second. Okay? Now, part B. How do we find the horizontal force exerted on the car? Make some room. To find what the force is, we use work net equals force net times displacement. So what's the net force going to be equal to? Work net over displacement. What's the work net? 5,000. The displacement is 25 meters. So this gives us a net force of 200 newtons. And again, look at what is the net force? The net force is this force right here. So this has to be 200 newtons.